All right, good morning, good afternoon, and good evening. It is 10 o'clock in the morning here in California. If you're looking for the data science, machine learning, MLOps, and Kubeflow meetup, you are in the right place at the right time. So let's just dive right into this Kubeflow workshop. And again, it's going to be revolving around how can we take Kaggle's disaster machine learning example, that particular competition, and then how can we turn that into a Kubeflow pipeline as easily as possible without having to do a ton of coding. So there's a way to get there, and I'm going to show you how to do that in this workshop. So a quick word about the instructor. I'm the guy that's been yapping here for the last 5 or 10 minutes. If you have any questions about any of the stuff I've talked about so far, or even about things in the workshop, feel free to connect with me on LinkedIn, and we can take the conversation there about whatever it is, whether you want to sponsor, whether you want to speak, you have a question about the workshop or the Kaggle project or any of that stuff, just connect on LinkedIn. It's always good to get networked with other machine learning and data scientists, data science enthusiasts. All right, so what are we going to cover here in the next 45 minutes or so? We'll do some real quick housekeeping about the workshop itself. We'll do a quick Kubeflow overview for those of you who have not sat through my 10-minute speed dating introduction to Kubeflow. So we'll do a quick Kubeflow overview. We'll cover notebook basics as it relates to Kubeflow. And then we'll look at how can we get the Titanic disaster notebook actually up and running. And then we'll look at exploring the Titanic disaster notebook. We'll basically go cell by cell, understanding what actually is happening in the notebook. Then we'll take a look at some pipeline basics. Basically, how can we actually turn this notebook into a pipeline? And then we'll actually turn it into a pipeline, and then we'll run it. And we'll actually view the results at the end. And then we'll wrap it up with some next steps. So a quick word about the workshop. This workshop is really intended for data scientists, DevOps people who have little or no experience with Kubeflow. In the workshop, like I mentioned, we're going to cover the Titanic notebook from beginning to end. We're going to be doing it inside of Jupyterlabs. We're also going to be using an open source Jupyterlab extension called Kale, which makes it kind of a point and click operation versus having to write a ton of boilerplate. And then we're also going to be looking at Kubeflow pipelines. What this workshop is not, it's not an in-depth machine learning course or a Kubernetes course. There's plenty of other resources that cover those topics. Here, we're going to focus on the intersection of Kubeflow and this particular Kaggle competition. But as you can notice, we have a bunch of stuff that's happening. Again, you want to go to the events page on Aricto or check the Meetup group next week for all the other events that are happening. So whether prerequisites for the workshop, it's helpful if you have some familiarity with cloud computing environments, AWS, GCP, or Azure. This is kind of not a laptop exercise, so having a general understanding of how the cloud actually works is helpful. The other thing that's helpful is having a basic understanding of cloud native architectures and Kubernetes concepts, things like pods and controllers, container images and volumes, et cetera. Having a rough idea how all that works may make sense because it'll explain a lot about why Kubeflow works the way that it works. Because it only runs on Kubernetes, and therefore it inherits many of the pros and the cons, so to speak, of that sort of an environment. It's also helpful on the machine learning side. If you know a little bit about algorithms and model training and parameter tuning, that's also helpful. So what's recommended kind of going into this is kind of for most of the workshops, or almost all the workshops, is going to be having at least a general understanding of Kubeflow, which I recommend doing the Introduction to Kubeflow Fundamentals course, or sitting through it at least. And it's also now really easy to install Kubeflow. So at least having gotten to a user interface, you'll be way ahead of the game. All right, so let's jump into it with some a lightning quick overview of Kubeflow. Now we have a whole 90-minute course that just covers the fundamentals of Kubeflow, but here we're just going to get it done in a few slides, just kind of to level set things. So the first question that we want to ask ourselves is, what does machine learning and data science even have to do with Kubernetes? And the reason why we want to answer this question is because we want to lead into a discussion about why Kubeflow should be considered for your machine learning workflows. So the first reason why you may want to mix up Kubernetes and machine learning is portability, right? The classic refrain is, I don't know, it worked on my laptop. I don't understand why it doesn't work in the cloud in a truly distributed environment, et cetera, right? So with Kubernetes, it kind of levels the playing field there, where you'd get a degree of write once, reproduce, and run everywhere, right? With the idea being that if Kubernetes can run on your laptop, on bare metal, on VMs, in the cloud, then arguably, as long as that Kubernetes environment can be replicated to a different environment, whatever you built on top of it should run there as well. So portability is a big thing, especially when it comes from how do I go from my laptop to the cloud, or how can I develop directly in the cloud and kind of circumvent the whole having to work locally. Microservices, right? So it doesn't really matter if you're using Kubeflow or not, but most fully realized machine learning workflows are going to interact with a variety of services, whether it be on the data side, on the security side, training, serving, all of those things typically are going to be discrete services that you need to interact with. Kubeflow is no different. It's actually not a monolithic executable or binary. It's actually a variety of different services that are integrated together that to the end user appear to be, hey, it's just a single platform, but actually underneath the covers, as we'll see in just a second, there's a bunch of discrete services. So when you need to pass data between those services, when you need security across those different services, you end up with a microservices-based architecture. So it goes without saying that Kubernetes and microservices, I mean, microservices is probably the #1 use case for why you may want to use Kubernetes. So support for kind of services-based architectures that are part and parcel with Kubernetes is a reason to consider using Kubernetes for your machine learning workflows. And the last one is going to be a little bit counterintuitive, meaning that everybody knows that Kubernetes is a great way to get access to resources that you need. But what's kind of odd is that in the machine learning space, oftentimes it's more important to actually spin down the resources that you've allocated to yourself, or that your IT department has allocated to you. And this is primarily driven around GPUs. GPUs are notoriously expensive. I don't think there's many scenarios where data scientists get hardcore exclusive use to their own kind of bank of GPUs. They're often a shared resource, therefore, and very expensive on top of that. So it's just as important to get access to those resources when you need them to train models and things like that. But it's also just as important to release those resources so somebody else can jump on it. So portability, support for microservices, as well as the ability to scale up and down are 3 reasons why Kubernetes is kind of a no-brainer for machine learning workflows. Okay, so what happens when you bring those 2 things together, machine learning and data science, if you're sold on the whole idea? Well, Kubeflow is the logical thing to go look at. The quick history lesson here is that Kubeflow is designed to be a machine learning platform that should serve 2 audiences, the data scientists, but also the operations folks that have to end up running those machine learning models in production. So it's an ambitious project, meaning that it has to be a complete toolkit if it's going to be end-to-end. It's got to do data and training and tuning and serving and monitoring amongst a whole host of other things. It was originally launched publicly in 2017 at KubeCon by Google, and Google started it as a way to externalize their TensorFlow extended experience. For those of you that care about open source licensing like myself, it's Apache 2.0 licensed all the way through. Okay, so we kind of briefly touched this, but it is an ambitious project. It's not a point solution, right? So oftentimes people get hung up on how does Kubeflow compare to MLflow, or how does Kubeflow compare to this or to that? And oftentimes they're comparing it to a point solution, right? That just does artifact management, or just does serving, or just does model development, or just does data engineering. The idea here is that Kubeflow encompasses all of those things. So you really want to think kind of platform to platform, or you want to compare very specific features inside of Kubeflow to point solutions, because there's just a whole host of things that it tries to provide. How can you visualize that, right? So up above in the top these are all kind of common tools. If you've been kicking around in the data science or machine learning space for a while, you know that there's a bunch of tools that you kind of have to stitch together. You can either build this stuff yourself, or you can kind of get things off the shelf, whether they be open source or proprietary. But at the end of the day, if you kind of want to run the thing end to end, somebody has to do all the integration work, right? So the beauty of it is that a lot of the technology that you see up in the top of the slide actually is resident as first-class citizens in the Kubeflow platform. So for example, all of the model building stuff here, so this would be Jupyterlab, this would be RStudio, this would be Visual Studio Code. Those are all first-class citizens inside of Kubeflow that are already integrated. All of your training stuff, PyTorch, TensorFlow, scikit-learn, like all that stuff is in there. Multi-step workflows, Argo, security, multi-user isolation with SDO, monitoring and observation using Prometheus and Grafana, all that stuff is built in. If you want to do other things on the serving side, there's Selden support, there's NVIDIA Triton server support as well. So a lot of the tools that you're probably already using or thinking about using or spent time and energy integrating, that work is already done for you when you go with a platform that's end-to-end like Kubeflow. So hopefully that visual kind of helps understand the sort of toolings that come into play and what the benefit of going with a platform is. All right, let's zoom out. Let's try to sort out, at least from an architecture standpoint, what are the core components of Kubeflow? And the core components kind of map to some of its core functionality. But what we want to focus on is kind of the dark blue cells in the center. So this is going to be your kind of core technology or your core features inside of Kubeflow. You've got your notebooks, you've got your volumes, you've got your operators. These are going to be things like TensorFlow, PyTorch, XGBoost, your hyperparameter tuning. So those of you that are using AutoML are interested in it. There's a component called Cadib inside of Kubeflow that manages that. Your artifact management, that's going to be done through MLMD. Obviously, your multi-step pipeline, you have to have some sort of a user interface to interact with all this stuff, a serving component, et cetera. And then you'll notice off to the right, in the lighter blue cells, there's additional functionality that's kind of underneath the covers. Things like SDO and Argo and Prometheus and Knative and a few other things. These are all technologies that are kind of transparently integrated into the platform, right? With no work that you have to do on your side. Now, and I guess the whole promise here is that if all of this can run on top of Kubernetes, then the idea is wherever we can run Kubernetes, given enough resources, right? CPU, RAM, and storage, we should arguably be able to run Kubeflow. So you can run on any of the public clouds, you can run it on premise, you can even run it locally on your laptop. And it should be here getting to this idea of, produce once and then reproduce anywhere and run anywhere at the same time. Now, if this all sounds good on paper, you might be thinking, wow, I bet this thing is super complex to install. And in a weird way, it actually is. You basically have three options to install Kubeflow. This assumes that you've got access to some sort of Kubernetes infrastructure, which for a lot of data scientists, they don't want to be in that business. So it may be a showstopper. But at Aricta, we've kind of tried to make that process as transparent and as foolproof as possible. So you basically have three options when you want to install Kubeflow. You could either use a package distribution, right, from any of the big cloud vendors, and set up your Kubernetes infrastructure and then deploy that stuff on there. That's called a package distribution. That's one way to do it. The second one is going to be the use of Kubernetes manifests. This is kind of the realm of the advanced user where, hey, I want to use this version of this component, and then I want to bring in my other thing over here. And then, so for people who want a high degree of control and want to manually install different components and kind of test it and integrate it all on their own, manifest is the way to go. There's now a third option, which is kind of the easiest way to get into Kubeflow, and it's Aricta's Kubeflow as a service. So it kind of turns deploying Kubeflow into a point and click operation. I'll post the link there in the chat. Comes with a 14-day free trial. There's no credit card. It's just a sign up. And you get plenty of resources to get started. 16 virtual CPUs, 60 gigs of RAM, 700 gigabits of disk. So enough to get dangerous, right, with your data science. And it abstracts away all the Kubernetes stuff. So you can just basically sign up, click deploy Kubeflow. Once Kubeflow comes up, you basically log in, boom, you're at a user interface, you're ready to start developing models. We'll show you how that works here in just a second. So this is, I think, going to be a really short demo, maybe 60 seconds at best, which is going to show us how to actually get Kubeflow deployed in what I believe is the simplest way possible. right? So here we've just basically signed up and then we've clicked the new deployment button, and it can take about 30 minutes because there's just a ton of pods and resources integration that needs to happen on the back end, but you don't have to do anything. You just basically have to grab a cup of coffee and wait. And then once the deployment is ready, you basically log in with the credentials that are generated when the deployment is created. You log in and you're at the user interface, right? And that's it. That's all there is to it. You don't have to know anything about Kubernetes. You don't have to download anything, etc. So I think if you're just getting started, this is a great way to get your feet wet with Kubernetes. All right, so next, now that we're kind of assumed your starting point is that you've got Kubeflow up and running, let's jump into some notebook basics before we actually jump into the Titanic notebook. So first, let's level set. What are Kubeflow notebooks? They provide a way to run web-based development environments inside of a Kubernetes cluster, right? So notebook servers are going to technically run as containers inside of a pod. The other thing that's kind of cool about this is that admins can provide standardized notebook images so that all the environment stuff, the packages, all the setup is pre-configured. So everybody can get the exact same environment or a customized environment from basically an image. So you don't have to basically waste any time recreating environments for at least notebook environments. You can basically take standardized images and just launch them super quick. And we'll show you how that's done in just a sec in the demo. Also, in an organization, you probably need to share notebooks and data, or maybe you don't, right? You want to isolate things. So there's role-based access control inside of Kubeflow, which makes it easy. And it also integrates with a bunch of enterprise identity management solutions as well. So those are two big pluses to running your notebooks inside of Kubeflow, is the security bits, but also the ability to create standardized environments from images, so you're getting what you paid for, so to speak. So what are the supported development environments inside of Kubeflow? There's 3 that are supported as first-class citizens. There's Jupyterlab, there's RStudio, and there's Visual Studio Code. However, we're dealing with open source here. So in theory, with sufficient hacking, any web-based IDE should work. And the little screenshots that you see there at the bottom right-hand corner is just kind of a quick shot of when you build a new notebook, you can see your 3 options are there: Jupyterlab, Visual Studio Code, as well as RStudio. We'll work through real quick in a short demo in just a sec how to actually launch a notebook. Now, for this purposes of this workshop, we're going to be focusing on using Jupyterlab. For those of you not familiar, Jupyterlab is just an open source web-based environment for creating Jupyter Notebook documents. Obviously, people use it for many other things besides data science, but at the end of the day, what we're talking about are JSON documents that follow a version schema, contain an ordered list of input and output cells. They can contain code, but also a bunch of other stuff, things like Markdown, things like math via LaTeX, plots, and rich media. We'll kind of see that as we're working through the notebook. So how does Jupyterlab actually manifest itself inside of Kubeflow? Because you can use Jupyterlab obviously on its own, but how does it actually manifest itself inside of Kubeflow? So the Kubeflow Notebooks web app, which we'll take a look at in just a sec, enables you to spin up Jupyterlab notebook servers. Now, in common practice, there's normally a one-to-one relationship between a notebook and a server. You can obviously do it different ways, but I think that's the most common way that I see it done. Obviously, because you're running the Jupyter Notebook inside of Kubeflow, you inherit the goodness of being able to create standardized images, but also take advantage of the security features built into it. Again, the idea here is that we're building notebook pods or servers directly on the Kubeflow cluster. And it's also easy, and we have a separate workshop just on distributed jobs, to submit single node or distributed training jobs inside of the Kubeflow Notebook application. Okay, that's the notebooks, or at least enough that we need to know to get dangerous. So now let's jump into getting the actual Titanic disaster notebook up and running. So if you're not familiar with the example, I'll go ahead and post that link here in the chat. So if you want to follow that link, you can learn more about the actual competition on Kaggle. But right, I didn't see the movie, so it's all news to me. But I'm sure everyone's kind of familiar with the story here, which is that in 1912, the Titanic sank after colliding with an iceberg. Obviously, there weren't enough lifeboats for everyone on board. That meant that about 1,500 people died out of 2,200 some odd passengers and crew. The idea here about the competition is that there was some element of luck involved in surviving, but some groups of people were more likely to survive than others. Now, of course, the goal of the competition is to predict who is going to actually survive the disaster based on a variety of different data points that you have about the individual passengers. And we'll look to see what those features are when we're working through the notebook. But again, the goal of the competition is to create a model that predicts which passengers are going to survive the Titanic shipwreck. Pretty straightforward, right? Okay, so up next is, before we can get this notebook up and running, we need to figure out, okay, how do we create a notebook for this particular competition? So when we're working through the Kubeflow UI, and we'll do this in a short demo in just a sec, but I want to prep you to see what you're going to, so that you understand what it is that you're going to be looking at. It's simple. We just go to the notebooks application, right? Or the notebooks menu option inside of the Kubeflow UI. We select our namespace, we click on notebooks, we click new server, we name our notebook server, and then we configure the notebook server. We just take a default image. In this case, there's an image already built into the Kubeflow app. And then you specify your CPU and your RAM if you want to modify that, and then create a workplace volume or a data volume if you want to do that, and click launch. It's actually super, super straightforward. No coding required. So let's go ahead and get the Disaster Titanic up and running. But first, I'm going to let my cat out of the office before it kills me. So with that feline catastrophe avoided, we're now ready to go ahead and get the Titanic notebook up and running. And these are the steps that we're going to show you how to, we're going to first work through them statically, and then we're going to show you in a demo how that actually all comes together. Of course, our starting point here is that we're assuming that we've already got Kubeflow up and running. We're going to click new notebook. We're going to name it. We're going to launch it using a default image that kind of ships with it. We're going to create a data volume called data. And then once the notebook is up and running, we're going to connect to it. And then we're going to navigate to the data directory that we just created. We're going to git clone the repo. Then we're going to navigate inside of that repo that we just cloned to grab the notebook. And then we just open it up, right? So this should be super, super straightforward. And this is akin to how you would do tons of other notebooks. So once you know how this process works, getting to a notebook should be a snap. So let's see how it's actually done. This quick demo, we're going to show you how to get Kaggle's Titanic disaster machine learning example up and running. Now, first, we're going to assume that you have Kubeflow installed and that you've done that via the minikf package distribution. We're in the notebooks view inside of the Kubeflow central dashboard. We click on new server. Now here, there's a couple of configurations that we need to make. The first thing is that we need to name our notebook server. In this case, let's just name it Titanic example. Then the next thing that we need to do is to select the appropriate image. The one that is in the dropdown by default is going to work. And then we need to also add a data volume. And we're going to go ahead and name that data volume just data. And that's all you need to do. Click the launch button. And after a few moments, our notebook server is going to be up and running, and we are ready to go ahead and connect to it. This is going to bring up the Jupyterlab interface. And the next thing we want to do is open up a Jupyterlab terminal. And we're going to want to, from the command line, navigate to the data directory. And then from the data directory, we then want to do a git clone, which is going to pull down the appropriate files, folders, as well as data. And once that's done, we're ready to then navigate to data, examples, Titanic ML dataset. And from here, locate the Jupyter notebook, double click on it, and we're now ready to start exploring. And that's it. That's how straightforward it is. So if you're interested in following along at home, you can view the notebook on GitHub. Don't need to install anything, nothing. Just click on that link and you'll actually see the notebook that I'm about to walk everybody through. So if you kind of want to preview it on your own machine, click on that link on GitHub, and that'll be the actual notebook that we're going to be working through. So that takes us to our next step. let's go ahead and explore this notebook that we now have up and running. So I'm going to statically walk you through what's happening in a notebook, and then we're going to work through it in a demo so you can kind of see how it all flows. So let's go back into presentation mode. So there's a couple of main sections inside of the Titanic notebook. There's an imports section, there's a load data section, data processing, feature engineering, our machine learning and algorithms section, and then there's a results section. So these are the main sections of the notebook. Let's double click on each one. On the first one, we're going to have an import section. So here what we want to do is that we want to import our libraries and our dependencies. So the things that we're going to be bringing in here are pretty stuff you should probably be pretty familiar with if you're doing data science. NumPy, which is going to give us math functions, algebra, number generators. Pandas, which is a data analysis library. Seaborn, Matplotlib, as well as sklearn, right? So these are the different things that we're going to be importing in. In the next section of the notebook is going to be the load data section. And as the name implies, here we basically want to load our data set. So there's two data sets that we're working with here. One is a training data set and one is a test data set. And we'll escape the presentation right now. And then let me see real quick. Let's get you so you can actually visualize what's happening in there live. Let's see, where are we? Kubeflow as a service. All right, so here's my Titanic notebook server. I connect to it. This is my notebook, right? This is what we're working through right now. And if you're interested in looking at what those data sets look like, they're in the data directory. Don't know why my double click's not working. Oh, because I'm logged out. All right, we'll have to log in some other time. But anyway, in the data directory is where you would find the two data sets, the training data set as well as the test data set. And this is just a quick snapshot of what that looks like in there, what those CSV files look like. So let's move on to the next section, which is going to be the data pre-processing step. So here, there's a variety of different things that are happening, but we'll just go ahead and highlight one of the pieces of work that we have to do inside of this section. In one of them, we need to actually combine two features so we can figure out what the number of relatives are, because we believe that maybe there's an element of, depending on the number of relatives that you have, maybe you stood a better chance of actually surviving. But in order to determine the number of relatives that a passenger had, we need to combine two features, and that's going to be siblings as well as parents. We can also see that this particular step, which you'll see manifest in a pipeline, there'll be a discrete pipeline, data processing pipeline step, that it depends on the load data step. Well, it makes sense, right? You got to load the data first before you can actually process it. There are also additional data processing steps in it, but I just wanted to highlight one to give you a taste of what's actually happening in that particular step. In the next section of the notebook is we have our feature engineering step. And this step is going to depend, as you can imagine, on the previous data processing step. So when we visualize this pipeline, that's the order that we're going to see things happen. Load data, pre-process, feature engineering. So here, there's a variety of different feature engineering things that we're doing, but I just want to call out one again to give you a flavor for what's happening in there. So it really all depends on what algorithms or libraries that we're using. Data is going to be expected to be numeric in a certain format. Maybe it's an image, maybe it's text, a string, whatever it is. But in this particular part of the feature engineering section, the task that we're doing is that we want to convert people's genders, or at least the passengers' genders, which is data that we had. They were either male or female, and we want to be able to convert that into zeros and one, so that we can then kind of work with that data. But we can't use male and we can't use female. We need to use a 0 and a 1. So that piece of work is happening here, but this gives you an idea of the sort of feature engineering that needs to happen in the notebook. Moving on to the next main section of the notebook is going to be our machine learning and algorithm section. So there's a variety of different, I think there's a total of 5 machine learning algorithms that we want to leverage here to see if we can't generate a model that's going to give us the highest rate of prediction. So the first 2 that we're using in this particular section is going to be random forest, which is basically ensemble learning. for classification, regression, and other tasks. And it operates by constructing a multitude of decision trees at decision time. The next one in this section is logistic regression, which in its simplest form is just a statistical model that uses a logistic function to model a binary dependent variable. So if we move on to the next three algorithms that we're using here, we're using a Gaussian naive Bayes, which is a variant of naive Bayes, and it follows the Gaussian normal distribution and supports continuous data. The next one that we're using is linear SVM, and then the last one is just plain old decision tree. So these are the 5 algorithms that we want to use to see if we can't generate a model that's going to give us the highest rate of predicting who's going to actually survive the disaster. And then our final section, I think this is the 5th section of the notebook, is going to be our results section. And this is going to tell us, or we're trying to specify here, what it should look like, right? What their outputs are, what the scoring is, and what the ordering should be. And we'll see this when we actually run the pipeline and we look at the results. This is what we want to see it formatted as. So before we actually run the pipeline, let's go ahead and do some pipeline basics so we understand exactly what it is that we're going to see. Now, a quick rewind. Kubeflow pipelines, all they are is they're a platform for building and deploying portable machine learning workflows. There's a user interface inside of Kubeflow for managing pipelines, but there's also SDKs that you can interact with. The idea here is that you want to be able to manage the training experiments, the jobs, as well as the runs. There is also underneath the covers an engine, right? You need some sort of engine for scheduling multi-step machine learning workflows. What's underneath the covers? It's Argo workflows, right? So Argo workflows, for those of you not familiar, is an open source workflow engine for orchestrating parallel jobs on Kubernetes, which makes sense. Kubeflow runs on top of Kubernetes. Why not use the best in class workflow engine for Kubernetes? So just a quick note that workflow executors are emissary based, starting with the 1.5 version, which released back in April, which replaced the old Docker executor. So just a quick note there for those of you following along at home. So let's take a quick visual tour of the pipeline's user interface and where everything is inside of Kubeflow, and then we'll jump into actually running the Titanic example or competition as a pipeline. So first, let's get familiar with the pipeline basics more generically. All right, in this quick pipelines demo, I want to show 3 things. 1, how to access the runtime execution graph of a pipeline. 2, how to quickly compare pipeline runs. And 3, how to view the artifacts associated with a pipeline. So the first thing that you want to do is within the central dashboard on the homepage, you want to navigate over to the pipelines view. So here we can actually see the pipelines that are currently recognized by Kubeflow. You can see our open vaccine model pipeline is there. If we click on runs, we can see the number of times that this pipeline has actually been run. So let's just go ahead and access the last run that we did. So here now we're looking at the runtime execution graph of the pipeline, and I can drill into different steps within the pipeline. In this case, we're going to zero in on the model training piece of it. I can get access to the input and the outputs, as well as the ML metadata, which is just a library for recording and retrieving metadata associated with this workflow, plus additional information around volumes and logs, pod information, as well as events. Now, the next thing that we want to do is how about comparing 2 runs? So here, let's compare the last run with the first run. And then we'll just click the compare runs button. And visually, I can see here that the delta between the 2 is going to be that our epochs are going to be different. I think 10 and 4 is what we're seeing there. So the next thing that we may want to do is let's view the artifacts that are associated with the pipeline. So here we're going to want to navigate to artifacts, and there's 2 types of artifacts in Kubeflow. There's metadata, which is going to be experiments, jobs, pipeline runs, and metrics. And these are going to be stored inside of a MySQL database. And then there's artifacts. This is going to include packages, views, large-scale metrics. Here we want to think time series. And these are going to be stored in an artifact store like Rock, which we've talked about previously in the course. And to access those, you just simply need to navigate to the URI that's available there to get access to those particular artifacts via the snapshot. And that's the quick tour of the pipeline's user interface. So with that being said, we're ready to jump into the home stretch, which is going to be, let's actually get this bird off the ground. So let's go ahead and take that notebook now that we have a general understanding of what's happening in it, and let's go ahead and deploy it. Now, before we do that, we don't want to get bogged down in writing a bunch of code, right? Writing code that's going to instantiate different components and create Docker images and all that stuff. We don't want to do that, right? We want a simple way of being able to take what is already in that notebook and getting to that visual runtime execution graph. Fortunately, there's an open source project that makes it really easy to do that. It's the Kaggle Jupyterlab extension. And the way that it works is you basically annotate cells in the notebook, right, by giving them tags. So for example, you specify, hey, this is an import. Hey, this section is a function. Hey, this section is pipeline parameters. This section is pipeline metrics. This is a pipeline step. Or maybe you want to skip certain cells. Maybe you're running it multiple times and you don't need to do certain steps. You don't have to write any of that code. You merely use point and click operations to tell Kubeflow, this is the way that you should interpret this group of cells, so run them accordingly. With the idea that you can, again, not have to get bogged down in writing domain-specific language. You don't have to figure out how to resolve dependencies. You don't have to do multiple, imports all the time after every single step. And you can actually automate it so that you can serve the best model, right? So there's all kinds of capabilities that are built into this particular Jupyterlab extension. So the way that we're actually going to do it is really straightforward. Now, we want to recall that a Kubeflow pipeline is just a component for building and deploying a portable, scalable machine learning workflow. We're going to skip all the workflow, and all we're going to do is essentially click the compile and run button, right? Because all of the cells have already been annotated. So we're basically clicking a button, and that's what's going to get us into our pipeline. And then as you saw in the UI demo, there's different ways that you can interact with the run. You can view experiments, you can view pipelines, and you can view runs depending on what angle of attack you want to take on it. And then the last part is going to be just viewing the results. And you can see our execution graph. The last one, the one at the bottom here, is the one that we're interested in. And you want to remember that in the results cell, we specified what our results should look like, how they should be ordered, what should be in there, how should it look. You can see this is going to be the output that we're going to see there. Now, let's go ahead and put this example in action. And if you're interested in following along at home, there is a whole tutorial that's free and it's on demand. You can click on that, sign up, and you can actually work through in greater detail exactly what this workshop is all about. But in the next demo, what we're going to do is that we're going to go ahead and enable the extension. You'll see quickly the difference that the notebook takes once you have your notebook pre-annotated. We'll do a quick exploration of what's happening in the notebook, similar to how we just did statically, but we'll see it actually live, so to speak, in the notebook. Then we'll convert the notebook into a pipeline, and then we're going to view the results to see which model is going to give us the best prediction for determining who is potentially going to survive the disaster. So let's get right into it. All right, in this short demo, which makes use of the Titanic disaster example, we're going to highlight a few things. The first one is we're going to show you how to enable the Kaggle Jupyterlab extension. We're then going to explore the various cells within the notebook to understand what exactly is happening inside of it. We're then going to convert the notebook into a pipeline, and then we're going to view the results. So to follow along at home, we're going to assume that you've already installed Kubeflow and that you've done that via the minikf package distribution, and that you've worked through tutorial number 1, which is going to feature the Titanic example. So with this as our starting point, let's go ahead and review what is happening in all the different cells inside of the notebook. The first thing to do is to go to the left sidebar, locate the Kaggle icon, and let's go ahead and enable Kaggle. You can see immediately in doing so that it's highlighted various cells within the notebook and has actually called out various dependencies. And ultimately, Kaggle is what's going to make it a lot easier to convert this notebook into a pipeline. So that's the first thing that you want to do, is to enable the Kaggle Jupyterlab extension. Okay, so the first cell that we look at is going to be our import section. So this is going to bring in our libraries, and it's going to bring in our dependencies. The next cell is going to be the load data cell, which, as the name implies, is going to load the data that we're going to use with the various algorithms that we want to test against it. And you can actually see or locate these particular testing and training data sets by going to the file browser, going to data, examples, Titanic ML dataset, data, and you can see the two data sets are there. The CSVs are there. So if you're curious about what the actual data set is, that's where you're going to be able to locate them. All right, so let's toggle back over to the notebook, and the next cells that we want to look at are going to be the cells in regards to data processing. So here in this particular step, at least we'll just take the first item here, which is going to be, we want to combine two features as the number of relatives. And the features that we're going to combine are going to be siblings, and they're going to be parents. And you can see that Kale makes it easy to understand what does this particular step depend on. And you can see that it depends on the load data step, which makes sense, right? You got to load the data first, and then you can actually process the data. And you can see that there's other data processing steps in regards to filling in missing data related to cabins, age, as well as embark features. Now, the next cells that we want to look at is going to be the feature engineering cells. So we want to recall that a feature is an individual measurable property or characteristic of a phenomenon, which is normally going to be numeric, but can also have structural features like strings or graphs, which are going to be useful in syntactic pattern recognition. Algorithms sometimes require that certain features have certain characteristics to work properly. So an example that we can look at is going to be this one here, which is where we want to convert the sex of a passenger into a binary format, meaning that we want to convert males into zeros and females into ones, because in order to leverage the algorithm that we want to use, that's what it's going to expect. That's the sort of data format that it's going to need. And then we can also see that the feature engineering step is going to depend on the data preprocessing step, right? Which makes sense. The next group of cells that we want to look at is going to be the machine learning and algorithms section, right? So in this section, what we're looking at is what are the different algorithms that we're going to want to make use of to find out which one's actually the best performing one. You can see we've got random forest, logical regression, and a handful of others there as well. And you obviously see Kale makes it easy to understand what the dependencies are in order for that algorithm to be leveraged. And then finally, we've got our results section here at the bottom. In the results section, what we're covering is what the results of the experiment should look like, and what the models that were used, the scores, and the ordering. Basically, what does that result set need to look like, and what does it need to be formatted like? So now that we understand what's actually happening inside of the notebook, let's convert the notebook into an actual pipeline. So here we're going to want to go back to our Kale widget. And if you look at the bottom of it, you've got a compile and run button. Let's go ahead and click the compile and run button. Now, what Kale has automated for us here is that it's going to validate the notebook. It's going to take a snapshot of the notebook, the data, everything that's coming with it. So if we need to revert to precisely this state, we can do that. So we've got our snapshot taken care of. Then we compile the notebook, we upload the pipeline, and now we're actually running that pipeline. You can see that as that kind of final status here. So let's go ahead and view the running pipeline. So this is automatically going to navigate us to the Kubeflow central dashboard, specifically to the runs view. And we can see here with the execution graph in a visual sense, we can actually see in real time what are the different steps that are being executed. So for example, we can see that the volumes have already been created. Right now we're in the load data process. And then we're in the data preprocessing step. Now we've moved into feature engineering. And now we can see the various algorithms being leveraged. And finally, we have our results. All right, with the run complete, we can now click on the results step, click on the visualizations tab, and we can then see which of the algorithms actually delivered the best results. And you can see that there's a tie here between random forest and decision tree. And you want to remember that we're looking for the algorithm that's going to give us the best results in relation to the original problem that we had, which was how accurately can we predict who will survive the disaster? And it looks like random forest and decision tree, at least with this experiment, are going to give us the most accurate results. All All right, and that was how you could use Kale to actually generate a pipeline from a notebook by using cell annotations versus having to write a bunch of code, which nobody I can imagine can think a lot of fun. At least this kind of code doesn't seem to me to be a lot of fun. So in the Q&A, we had a couple of questions. So I did, while the demo was playing, resolve my login into my environment here. So here we're basically looking at the Kubeflow UI. You can see that I'm on the notebooks menu option. So you can see I have a bunch of notebooks here. And specifically, we want to go into the Titanic notebook server that I have. Before I do that, there's a way to specify GPUs, right, when you're actually creating a new notebook server. And you can see it's this option here where you can specify the number of GPUs as well as the vendor that the GPU or the architecture that's being used. So that's one spot in which it's specified. The other one is in the notebook itself, right? So here we're in the machine learning algorithms section of the notebook. Remember, we had random forest, decision tree, logistic, like we had 5 different algorithms that we're using there. So let's just say for the random forest one, we want to specify GPU usage. You can see that when we use Kale, we don't have to write any code. We just click a button. We then specify what the GPU count is, as well as whatever the vendor type or architecture is that we're using. And then we know that when this step executes, right, we want to make sure that a GPU is being used in however, specification that we've given it. And you can remember that when we look at the runtime execution graph, let's just say we did that for random forest, then in this particular step in the pipeline, that's where our GPUs, whatever our allocation was or specification is, that's where it's going to be used. Then there was a follow-up is, okay, how do you specify GPUs if you're going the route of a mini cube installation? So there's actually a knowledge base article that you have to do some tweaks behind the scenes, because I think depending on how you've installed it, there may be, I think, Vagrant or VirtualBox or a few other things that kind of come into play depending on how you set it up locally. So I'll have to dig up that URL, but I know that we have a knowledge base article on how do I specify GPUs with a Minikube installation. So those are I think the 3 questions that we had around a GPU. So hopefully that kind of resolved that. So let's go ahead and wind things up, because I think we are near the end. So let's wrap it up with some next steps. Just to recap, can you get a summary of the Q&A? Is this being recorded? Yes. Look for a link on Monday inside of our recap blog. So it's going to get posted to the Meetup message board, but also if you follow Aricto on social, you'll see it posted on Monday, the link for it there, or just check in on the aricto.com/blog for the full recap, all the links, playlists, all the GitHub repos, the tutorials, all that stuff that you need is all going to be there. And quick summary, there's tons of workshops that we do. I think we do 2 a week at a minimum. So there's lots going on. aricto.com/events, or check back on meetup.org. Next week, I should have the calendar fully loaded for the next 90 days or so. There's also tutorials as well as lab-based on-demand exercises that you can do. So academy.aricto.com. So if you want to basically apply the theory to real-world examples, they kind of give you a problem and then you get a partial solution. Then you have to kind of figure out the rest of it. It's all free, hands-on labs, self-paced, kind of go as you have time. Academy.aricto.com is a pretty good learning source. So with that said, I want to thank everybody for hanging in there with me. If you got any questions, I'm happy to help. You can either hit me on Kubeflow community Slack. Well, I guess not hit me, but whatever, ping me as a DM, or we can connect on LinkedIn, and I'll repost my my LinkedIn handle here if I can find it there. And that's it. So if I'll go ahead and leave the Q&A open for another minute or so if there's any burning questions, but remember to make sure to vote for your favorite charity. I'll repost that link here. Super simple. Just join Kubeflow community Slack, vote for your favorite charity. We'll donate $100 to whoever the charity is that wins. It's a simple, easy thing to do for other people today. So not much energy required to do something good. And Somebody asks, is Kubeflow useful to deploy models to endpoints? Yes, absolutely. So let me actually exit this, and I'll have to locate where did I put my Kubeflow as a service? Here it is. And I'll have to figure out, okay, I'm here. And then if I go to models, right? So this is kind of the inference serving piece of Kubeflow. Under models, you can see that I actually have a model server actually running. And this is actually for, a model that helps companies understand, given the condition of a piece of heavy equipment that I have, like a bulldozer or a backhoe or a dump truck, based on its condition across multiple dimensions, its age, its mileage, whatever, like all these different dimensions, what is the expected price that I could fetch for it if I put it up for auction, right? So we can just double click on that model, and behind the scenes, this is using Kubeflow's native serving component, KF serving, or what is now known as KServe, which is part and parcel. It's integrated into Kubeflow. But you can obviously also swap in things like NVIDIA's Triton inference server or Selden server. Those two things are supported as well. But you can see here is my model that I'm serving out. You can see I've got my external and internal URLs and a variety of different details, metrics, logs, YAML, all that good stuff is there, right? Hopefully that answered, that makes sense, right? And then I guess one of the other things that people often ask is, what about tensor boards? So here I have a tensor board set up for this exact same model, and we can just kind of connect to it. And you can see here as well that tensor board is kind of supported as a first-class citizen inside of Kubeflow. Because you want to remember, the idea is that if you're using a lot of these open source tools and you're spending time and energy kind of integrating them in so you can kind of get an end-to-end flow, Kubeflow does a lot of that for you by integrating all that stuff out. And one thing that's super cool that we cover in our AutoML hyperparameter tuning course, but you do see it manifest in a couple of the different workshops, is the AutoML piece, right? So here, this one is based on Udacity's dog breed classification course, which is, you have a model and then you basically feed it an image and it determines, is this a dog or is it something else? And if it's a dog, can I determine what breed that it is? So there's a variety of different kind of hyperparameter tuning exercises that you can do to kind of optimize that model. But there's a whole separate course that we have just on hyperparameter tuning that leverages that component. So again, Kubeflow is an ambitious project, end-to-end, something for data scientists, but also something for operations folks and kind of everything in between. So with that said, I'm going to once again thank everyone for turning out, and hopefully we'll see you either online on LinkedIn, happy to connect, or we'll see you at a future meetup and or training. So with that said, I'm going to go ahead and close the video and close the session. And thanks again, everyone. We hope to see you soon.